Hello, in this section we're going to look at another way of summarizing data with a single number. And this time, instead of looking at the number that measures the central tendency of that data, we're going to look at a number that will help us figure out how that data is spread out around that center. We've already kind of looked at a visual way of doing that with the 5-number summary and the box and whiskers plot. But we're going to look at another couple of ways of, specifically 2 ways of finding a single number, which will help us represent how that data is spread out. So let's go ahead and get started with this section. Okay, so these numbers that will help us determine how the data is spread out, we call those measures of dispersion. And the first one is probably the simplest one. It's just the range of the data. And the range of the data is really just the maximum minus the minimum. And sometimes that's helpful to know, and sometimes it's not very helpful. Another thing that we can look at is the deviation from the mean. So if I have the mean, which we said several times ago was x bar, and if we say that the data point that we're interested in is x sub I, that's the data point, then the deviation from the mean is just the difference between that data point and the mean. It just kind of says, here's how far away from the mean we are. The standard deviation is really just an average or a mean of how far each point in the data set is from the mean. So another way of saying it is it's the mean distance from the mean. Alrighty? And that's one that we're going to look at pretty heavily here. The variance is really just something that goes along with the standard deviation. And the easiest way to say the variance for our purposes is going to be that it's the standard deviation squared. Alrighty? Then the last thing that they talk about in some of the problems is the coefficient of variation. And the coefficient of variation is the standard deviation, I'm just going to initial that SD, divided by x bar times 100%. So you turn that into a percentage. All right, so let's look at a example here. And what I've got is the table below gives the annual incomes for 8 families in thousands of dollars. Find the measures of dispersion and find the standard deviation. So if we look at our numbers here, the range is real quick and easy. What we're going to do is we're going to take the maximum value, which is 63, minus the minimum value, which looks like 35, and our range is just going to be 28. So we have a range of $28,000 in annual incomes. Okay? Pretty quick and easy. Now, in order to find the standard deviation, remember the first thing we said it was the average of the deviations from the mean. So the first thing to find out is what's the mean. And the mean is going to be the sum of all these numbers. So if I add up all of those numbers, and I did that already, I get 387 divided by the number of numbers we have, which is 8. So that's going to be 48.375. That's our mean. So our mean income is $48,375. Now, in order to find the standard deviation, what I'm going to do is I'm going to start with the different numbers that I have. So I have 47, 48, 50, 49, 51, 35, 44, and 63. Then what I want to do is I want to find the deviation from the mean for each of those numbers. So that would be 47 minus my mean, which is 48.375, which is negative 1.375. And then I would do that for each of these. 48 minus 48.375, which would be negative 0.375. 50 minus 48.375. 49 minus 48.375. All right, and I get, for all these, 1.625, I get 0.625, I get 2.625, I get negative 13.375, I get negative 4.375, and I get 14.625. Okay, so those are my deviations from the mean. Now what I'd like to do is I'd like to find out what the average of those deviations is. But notice if I was to add up all of those numbers, and you can do this on your own, if you add up all those numbers, it comes out to be 0. Not very helpful. And the reason why it's 0 is because some of them are below the mean and some of them are above the mean. So one thing we could do is we could take the absolute value of those numbers, but that's not going to be as helpful as what we're going to do. There is a way of doing that, and we're just not going to do it in this book. But there is a way of using that. What we're going to do instead is we want these all to be positive, so we could do the absolute value, or if we squared all these numbers, we would also get positives. So I'm going to take all these numbers and I'm going to square them. Alrighty, and when I square those, let's see, I'm just going to write down my numbers. Let me go ahead and hit pause, and I'll write down all my numbers, and then we'll come back. So here's what I got after I squared them, and I rounded these off a little bit. And now I want to find the average of those numbers. So how do I find the average of those numbers? Well, I'm going to take and I'm going to add all of these up. And I did that already, and I got 423.875. Now, I would typically divide this by the number, that's the sum of all of these. I divide by how many there are. So there's 1, 2, 3, 4, 5, 6, 7, 8. But what I'm going to do instead is I'm going to take that and divide it by 8 minus 1. And I'm not going to go into why we do that. It has to do with degrees of freedom and a lot of other things from statistics. But basically, it's the average but modified just a little bit. So I'm going to find that number. And so 423.875 divided by 7 gives me 60.55. Alrighty? And now, what I'm going to do, my last thing I'm going to do is I'm going to take, remember we were squaring all of these? So I want to get back to the actual deviations. So I'm going to undo those squares by taking the square root of that. And that's going to come out to be about 7.78. And that is going to be my standard deviation for this set of data. Now, there's a fancy way that we can write that. So let me just show you this fancy looking formula. We can say that the standard deviation can be found in the following way. What we do is we we find all these deviations from the mean. So we take xi minus x bar, and we do that for all of our deviations. So what I'm going to do is I'm going to say that I'm going to sum all of those. I'm going to do that for a whole bunch of them. Then I want to find the average, so I'm sorry, I'm messing this up. Okay, let me go back again. So I'm finding the deviations from the means, and then I'm squaring all of those. Then I'm finding the average, so I'm adding those up, and this symbol right here says add them up. I'm going to add all those up, and I'm going to divide by not the n, but n minus 1. And then I'm going to undo that square by taking the square root. So here's the formula that says what we do to find standard deviation. Now let me show you how to do it on the calculator, because this is pretty nifty. So if you take your calculator, and I have some data in there from last time. So what I'm going to do is I'm going to clear that data out. And in order to do that, I go up to and highlight the L2. And I'm just going to hit the clear button and then hit enter. And it's going to clear that out for me. I'm going to also clear out L1. And now I'm going to put in my data. So my data was 47, 48, 50, 49, 51, 35, 44, and 63. Now, if I go back to stat and I go over to calculate, and I want to calculate a one variable stat, I could put in L1, but by default it always goes to L1, so I could just hit enter. Notice it gives me my mean up here, which is what I determined, 48.375. Alrighty. And then down here, I've got two numbers. I've got 7.78, and I've got 7.29, or 7.28. And those two numbers are two different ways of calculating the standard deviation. The second one is the way in which we have just an n here. Okay, if we just have an n here, that's the value that we get. If we have this n minus 1, that's the standard deviation that we get. In this course, what you're going to be doing is using this formula, the n minus 1, which is going to be this Sx. And then notice it also gives you your five digits or 5-number summary. All right, so that's how you can use the calculator to find standard deviation. All right, there's one other way that the data is often given, and they want to find standard deviation for it. So in this one, the table below gives the ages of 16 World War II veterans who are attending a reunion commemorating the Normandy invasion. Find the mean and standard deviation of this data. So notice this time, instead of just having a list of data, they're saying there was actually 4 people who were 82. There were 2 people that were 83, 4 that were 84, et cetera, et cetera. So if we want to find the mean of this set of data, we have to say that there's 4 82s, and I could write 82 plus 82 plus 82, or I could say 82 times 4, plus 83 times 2, plus 84 times 4, plus 86 times 2, plus 93 times 3, plus 95 times 1. Divided by, well, we know there's 16, so 4 plus 2 is 6, plus 4 is 10, plus 2 is 12, plus 3 is 15, plus 1 is 16. So you could have 16 down here, or 4 plus 2 plus 4 plus 2 plus 3 plus 1. Okay? And when you do that, let's just see what we get here. We're going to get 82 times 4 plus 83 times 2 plus 84 times 4 plus 86 times 2 plus 93 times 3 plus 95. And that gives us a total of 1376 divided by 16, which is 86. Now what we can do is we can come down here and we can list our ages, so we have 82, and we could list that 4 times, or we could know that we're going to have to take care of the 4 over here, just like we did up here. So we have 82, we have 83, we have 84, 86, 93, and 95. Those are our ages. Our deviation from the mean, 82 minus 86, gives us 4. 83 minus 86 gives us, negative 4, negative 3. 84 minus 86 gives us negative 2. 86 minus 86 gives us 0. 93 minus 86 gives us 7. And 95 minus 86 gives us 9. Then what we're going to do is we're going to take these and we're going to square those out. So negative 4 squared is 16. Negative 3 squared is 9. Negative 2 squared is 4. 0 squared is 0. 7 squared is 49. And 9 squared is 81. Then I want to add all of these deviations squared, just like I did up here. So I'm going to say I want 16 times 4 of those, plus 9 times 2 of these 83s, plus 4 times there was 4 of those, plus 0 times there was 2 of those, plus 49, and there was 3 of those, plus 95, and there was, 81. 81 was what that was, deviation squared, and there was 1 of those. And then remember we have 16 minus 1 is what we want to divide by. So when we do this, we get 16 times 4 plus 9 times 2 plus 4 times 4 plus 49 times 3 plus 81. We get 326 divided by 15, which is about 21.7333. Then, remember, I have to undo this square, so I'm going to take the square root of 21.7333, and that gives me about 4.66. So standard deviation just kind of tells us, on average, how far away are our numbers from the 86. Okay, and they're on about that on average. Notice if we do that on the calculator, okay, I'm going to edit, and I'm going to go over to L2 here. I'm going to put in 4 82s, 2 83s, 4 84s, 2 86s, 2 93s, and 95. And then I'm going to go to one variable stat, and I'm going to do it for L2. And it gives me my average. I must have missed something here. Let me check. So I've got 1, 2, 3, 4 82s, 2 83s, 1, 2, 3, 4 84s, 2 86s. Oh, I forgot a 93. All right. So now let's go back and calculate one variable stats with L2. Okay, so our mean is 86, which is what we thought, and our standard deviation is 4.66, which is what we got. Alrighty, so hope that helps.